Podcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for joining our webinar. This session is called Choose Flexibility, Positioning, and Centering Solutions. Will be presented by Paul Opalinski. I'm going to transfer over to Paul now, and he can begin.
Thank you, Brian. Let me just pull up my presentation here, and we'll get started.
All right, looks great.
All right. So, as Brian said, we're going to talk about positioning and centering solutions. We're going to cover two topics today. One of them, the first one, we're going to discuss electric actuators to meet your motion requirements, including custom speeds, stroke lengths, and different applied forces. In addition, with the electric actuators, we're also going to talk about the recent addition of battery-less absolute encoders that we have added to our LE series and the advantage that they offer compared to incremental encoders. The other topic that we're going to cover is the MACM series, which is a newer solution from SMC, and it's used for centering workloads to help align and position heavy work pieces on conveyor systems. So let's get started with the electric actuator portion. There we go. So with the addition of absolute encoders to our electric actuators, there's a few advantages to our product compared to what we had in the past. In the past, on our DC stepper electric actuators, we mainly focused on incremental encoders. Over the last year or so, we started introducing battery-less absolute encoders. The advantages of those are no need to do a homing routine or a return to origin routine. The actuator's position will be available upon power on. So there is no lost position when we're first powered on. The actuator controller always know where they are. Additionally, since it's a battery-less type of absolute encoder, there is no need for battery replacement on the encoder itself. In addition, with no battery, there is no issues to address when importing the controllers with the battery, as well as no need for disposal restrictions on the battery themselves. What you see on the bottom of this screen of the slide is just a few of the different offerings that we have on our electric actuators that are available with the absolute encoder. I'll start on the left-hand side, work my way to the right. So the first grouping that you see is our LEFS, which is a ball screw driven electric actuator slide. These are offered up to 2,000 millimeters as a standard product. Multiple sizes available with different motors, different speeds. Next to it, towards the bottom, similar slide. This one's a little bit different on the mechanical side. It is a belt driven one. So for applications that may not require higher force for higher workloads, but do need higher speeds, this is where the belt-driven LEFB series will come into play. Towards the middle of the screen, you'll see 4 different types of actuators that are a rod type actuator. They are ball screw driven. The difference between the two, one is just the rod itself, while the other one has a guide system attached to it for additional side load capability. With these actuators, they are typically used for moving higher workloads as well as lifting workloads in a vertical application. The remaining ones on the right-hand side of the slide are more so on the compact side. So we'll see slide table, 2-finger grippers, as well as a rotary actuator. Nice part about them as well, they're offered in different sizes, different strokes, depending on the needs for your application as needed. Just to go over a little bit information on the type of absolute encoder that we are using that has been recently introduced. We are focusing on the battery-less absolute one that you see on the left-hand side of your screen. And we're kind of comparing it to the other types of encoders that you might find on some of our older products, as well as some of the other electric actuators available from various manufacturers. So all the way on the right-hand side, incremental encoder is something that we used for a long time on the DC stepper side of our electric actuators. The limitations on that is it does require a homing procedure. We refer to it as homing, return to origin, but the purpose of that is for the encoder itself to recognize where the zero position or the home position of that actuator is. This is something that is required when the controller actuator are first powered on, or at any time there might be a power loss. Next to that, we have a pseudo absolute encoder. The difference with this one is it operates like an absolute encoder, meaning it will remember its position, but it does require a battery as a backup to store that information. And there is a limitation on that one, maximum of 20 days. Otherwise, that homing procedure has to be repeated. An absolute one to the left of that, in addition of not having to home, it does require a battery. So this is common on some of the AC servo controllers that we have, and moves us over to the current one that we're talking about, the battery-less one. You kind of see the information provided, no homing required, no battery required, no data memory limitation. So it will remember its position even with no battery. There's no time limit on that. The way the battery-less absolute encoder works is there's 3 different wheels connected or in use, and they are driven by worm gear. The main wheel that you see in the image, the blue color, it rotates when the motor rotates, and when that wheel rotates, it will move that worm gear, the worm drive, around. Once that worm drive is in motion, the other 2 sub wheels, the yellow and the green one, will rotate as well. Because they all have a different number of teeth on the wheels themselves, the angle sensor will give us different signals for different positions on the actuator itself. So different combinations of where they are positioned will reflect a different position physically on the electric actuator itself. So if it's a rod type 1, it'll tell us how far that rod is extended. If it's a slide type, it will tell us where that slide is on that actuator itself. With the new introduction of our absolute encoder, we've also introduced a new line of controllers that work with the absolute encoders. So you can kind of see the different types of series, the JXC, and a few different alphanumeric characters after it. Those spell out different types of networks that are supported on those. So you will have access to parallel I/O or discrete I/O if you choose to connect that way, CC link, EtherCAT, Ethernet IP, so on, as well as I/O link. These controllers will work with incremental encoders as well as the new type of absolute encoder that we introduced. So if your application calls, it requires the absolute encoder, the controllers that you have been familiar with will offer you that capability. One thing I'll quickly add, with the JXC series of controllers, you have 2 choices available for how they are programmed and set up on your machine. One of them being our ACT software. With this piece of software, which you can download from our website, you are able to program different step data into the controller, such as speed, position, acceleration, deceleration. Additionally, if you choose not to use our software, we also offer direct numerical instructions sent from the PLC to the controller itself. So that's a nice advantage with the new JXC controllers, where you're able to change the information on the fly from the PLC or the HMI itself. One of the advantages on the absolute encoder itself that we mentioned before is no need to origin or restart on a restart. So you can kind of see on the bottom right, there was a power loss on an incremental encoder. We would have to do the return to origin where it goes to one of the ends of the actuator itself. With the absolute encoder, wherever you start up, the controller actuator knows that position. As we mentioned, no battery needed, so free from maintenance on the battery and no need to worry about recycling that battery. And here's just a quick application example of where it might be beneficial to use actuators with absolute encoders. Here we have 3 of our electric actuators. The slide itself is in a horizontal position. To it is mounted a slide table, to which is mounted a gripper. In an application such as this, if we had a power loss and we were in the middle of, for example, moving that blue block from one conveyor to the next, with an incremental setup, we would have to restart that position and maybe even reposition some of those parts on the conveyor. With an absolute one, even if we're mid-process, for example, the gripper's already picking up that piece, we could start from that once power is brought back online and just continue with the operation. So that was the portion on the electric actuators. Let me just quickly check if there's any questions in the chat. Not at this time. All right, so the other topic we were going to talk about is the MACM centering unit. This unit is used for alignment and positioning of transferred workpieces on conveyor lines. So the purpose of it is to align the workpieces on the conveyor using small cylinders, resulting in smaller, compact conveyor lines because larger pneumatic cylinders would not be required. The centering unit itself comes in multiple different sizes. The largest size allows up to 1,000 kilograms or 2,200 pounds as the load that is applied to it. The workpieces themselves can be moved in any directions, forward, backward, right, left, any of the angles. It could even be rotated. So there's no limitation on that end which way the workpieces are moved upon that centering unit. In addition, we'll offer 4 different types of material. So you can see on the bottom left, 2 different types of stainless steel, different finishes, a polyethylene coating, as well as a cast nylon piece as well. The largest movable range on the MACM line is 1,000 millimeters, so about 4 inches side to side. Here, we'll kind of go over an application example. So you could see in the first step, as the workpiece approaches the centering unit, it is skewed at an angle. When it comes to the centering unit portion, there is cylinders that will pick up that workpiece on the centering unit itself, as you see in number 2. What happens next is when it is picked up on that centering unit, the alignment cylinders that you see on either side of the workpiece will push it accordingly to align it to be centered across that conveyor line. Once that is done, the centering unit descends, as you see in number 4, and the workpiece is returned to the conveyor system in an aligned orientation. The working principle behind the centering unit is shown on these images. What is happening here is when we use the centering unit in an unlocked position, the table is free to move along the bearings to the position it needs to be. So as we mentioned previously, forward, back, left, right, or rotation. While that table is being moved around, there is a spring internally which will allow that table to return to its center once the load is released. Here we can kind of see the unlocked condition versus the locked condition. The main difference with this is on the left-hand side, the port that is shown as unlocked will have compressed air running to it, not allowing the centering unit to be locked in position. Once we have a workpiece on it orientated the way that we need to be, we will supply air to the locking port, and that way the bearing holding plate is held in place. The table is not allowed to move. So in that setup is when we will return that workpiece to the conveyor system and release the lock once we lower those actuators. So that looks like that would be the majority of my time at this point. I want to thank everybody for joining. Let me just check quickly if there's any questions in the chat.
No questions right now, Paul. Thank you for your presentation.
Okay. So if anybody has any questions, feel free to unmute yourselves or reach out to us, to your local rep or in the chat below. Thank you for your time.
Thanks again.